Good day, grade 8. I am your teacher, Marie.
Good day, grade 8. Now we're going to discuss a new topic. Let us enjoy watching while learning.
Reasoning and proof. Equivalence of converse, inverse, and contrapositive of an if-then statement. In mathematics, making conjecture or valid conclusion is very important skill. In this section, we will encounter statement presented in more logical way that involves comparison of objects. Every day, we are dealing with different situations. These life situations are filled with conditional statement. Again, conditional statements are either true or false condition. The following table show comprise when the statement PQ is true. Again, P is our hypothesis, Q is the conclusion, then PQ is the conditional statement. If our hypothesis is true, then our conclusion is true, then the conditional statement is true. Then, if our hypothesis is true, then our conclusion is false, the conditional statement is false. Another, if our hypothesis is false, then our conclusion is true, then the conditional statement is true. And then last, if our hypothesis is false, then the conclusion is false, the conditional statement is true. Let us try this example. First, if a quadrilateral is a rectangle, then it has two pairs of parallel sides. If we're going to have the converse statement, if a quadrilateral has two pairs of parallel sides, then it is rectangle. It is a true statement. Then the inverse, if a quadrilateral is not a rectangle, then it does not have two pairs of parallel sides. So, it is a false statement because not at all times that we have two pairs of parallel sides is a rectangle. We have the contrapositive. If a quadrilateral does not have two pairs of parallel sides, then it is not a rectangle, which means it is a true statement. Have you noticed something special on example? This reminds us that the converse and the inverse of a true statement may not necessarily be true also. The truth of the converse, inverse, and contrapositive of a conditional statement is given by the table below. You have noticed that the truth table of the conditional statement is the same width of its contrapositive. On the other hand, if we have the converse and inverse, we have the same truth tables. Now, let us have discussed the inductive and deductive reasoning. Inductive method, the method of inductive reasoning start with particular cases to generalization is derived from the observing of trend of particular cases. Deductive method, this method begins with a known fact to produce another fact. Rules of logic are applied on this known fact to arrive at certain conclusions. Let us have an example number 1. Show the sum of two odd integers is even. This problem requires deductive reasoning. One can start with the fact that odd number can be written in the form of 2k plus 1 for all integer k. 2k plus 1 plus 2k plus 1 is equal to 4k plus 2. Then, getting the common factor, so 2 times the quantity of 2k plus 1. Let p is the integers, then p is equal to 2k plus 1. So, we have 2p. Since p is also an integers and 2p is even, we have shown that indeed the sum of two odd integers is even. Example number 2. Complete the sequence of numbers 2, 5, 11, 23, 47. Unlike the first example, particular cases were given. This is case for inductive reasoning. Notice that 5 is equal to 2 times 2 plus 1. Then 11 is equal to 2 times 5 plus 1. Then 23 is equal to 2 times 11 plus 1. And 47 is equal to 2 times 23 plus 1. So, we can conclude that the general term a sub n for this sequence is a sub n is equal to 2a sub n minus 1 plus 1. Thus, the next three terms are 95, 191, 383 in that order. But again, as mentioned earlier, they should be verified via deductive reasoning. Patterns of deductive reasoning. To arrive a valid conclusion, we need to apply logic appropriately in step of our reasoning. Commonly used pattern of deductive reasoning will be discussed in preceding paragraphs. We have the law of detachment or the modus ponens. In direct proof, one builds on true statement while the other statement have already been proven true. This is the typical format for the two-column proof. This method includes the law of detachment or the modus ponens, which state that if P, then Q. Q is true and P is true. Then we have concluded that Q is true, or the conclusion is true. This law implies that we have known that the hypothesis of the conditional statement is true. Then we can accept that the conclusion is also true. The following illustrate how we can arrive at the conclusion applying law of detachment. First example, if you cheat, you are dishonest. Paul cheat. Therefore, Paul is dishonest. Example number 2, if n is greater than 0, then an is greater than bn for all real number. Since n is greater than 0, therefore 3n is greater than 2n. Law of indirect reasoning or the modus tollens. Indirect proof use negation. Negation means to take the opposite or to falsify a true statement. If the statement is P, then the negation is not P. What this law implies is if we can show the negation of the conclusion is true, then the negation of the hypothesis, not the hypothesis itself, is also true. As we discussed, by negation we mean to contradict a statement. The following example illustrates the law of indirect reasoning. Example number 1, if today is Saturday, then I will be date you. I did not date you, therefore today is not Saturday. Example number 2, if you lie, then you are reprimanded. You are not reprimanded, therefore you did not lie. Logical arguments are always presented in court of law. Lawyer must be very articulate with the laws and the conclusion drawn from these laws. The lawyer gathers facts and evidence which are necessary to gain variables which are supported by the law. Writing a proof can be one of the changing things to do in geometry. The proof is a form of logical reasoning in which each statement is organized backed up by the reasons. The idea of an argument must be presented clearly in the convincing way. It is definition, understand and remember the definition, undefined term, postulates, theorem, properties, and axioms.
Thank you. Enjoy watching while learning. This is your teacher, Miss Marimar F. Figalan.